Hello friends, welcome you all in our YouTube channel Let's Learn and Grow Together in the course of Engineering Metallurgy. Today we are going to see the next part, that is cooling curve. Cooling curve. So in the last lecture we have studied the Gibbs phase rule, that is P plus F is equal to C plus 1. P plus F is equal to C plus 1, where P is equal to number of phases, F is equal to number of degrees of freedom, and C is equal to number of component. One is equal to any variable out of temperature, or we can say concentration, temperature or concentration. Okay, so this Gibbs phase rule we have studied in the last lecture, and today we are going to study the cooling curve. So what is the cooling curve? What we can say, that cooling curve is a line graph that represents change of phase of matter, typically from gas to solid or liquid to solid. Means this is one type of the curve, and this curve will give the information about the change of phase, or we can say matter, change of phase or matter, means from gas to, we can say, solid, or from liquid to solid. And the independent variable is time. So here in case of cooling curve, the independent variable is that is time, and this we are writing on the x-axis, and dependent variable is on, we can say, and that is nothing but the temperature that we are plotting on the y-axis. Means suppose if we consider, suppose this will be the y-axis, this is x-axis. On x-axis there is a time, and on y-axis there is a temperature. Okay, so these are the two axes. X-axis indicate the time and y-axis indicate the temperature. Time is independent quantity while temperature is dependent quantity. Okay, now next what we are doing, that if we plot the curve, in that case we will plot the curve like this. Okay, now in that case, from A to B, B to C, C to D. Okay, from A to B we are getting liquid region, from B to C liquid plus solid, and from C to D we are getting the solid region. Okay, now in this what we can say, this is nothing but the thermal arrest, because from point B to C temperature remain constant. Okay, this point C means here we are getting the freezing temperature, means from point C to D we are getting the freezing temperature. freezing temperature. And here from A to B we are getting the pouring temperature. Pouring temperature. Okay, and what we can say, from B to C, from point B to C, this will give the information about local solidification time. Local solidification time, that is LST is equal to local solidification time. Local solidification time. Okay, and from point, what we can say, from this 0 point, okay, we can consider this point as a 0. From this point to C point, this will give the information about total solidification time, that is total solidification time. So here I can write TST is equal to total solidification time. Okay, so what we can say, that this from point, initial point to this C point, we are getting the total solidification time. Now here what we can say, that when the phases of the materials are going to changes, means from liquid plus solid, and then we are getting the solid state. Okay, so what we can say, that the amount of energy required for a phase change is known as latent heat. Means what we can say, how much amount of energy is required, that is energy required to change the state, or we can say to change the phase, is known as latent heat, Okay, so this is the cooling curve. This type of the cooling curve we have to study for different materials. Okay, thank you so much. Next part we are going to study in the next lecture.